Hello everyone. Okay, so in this video we're looking at standard deviation and how to calculate it. So we're going to be looking at context and applications of standard deviation in the next chapter in relation to like normal curves and hypothesis testing, etc. But all you need to know about standard deviation is, first of all, we denote standard deviation by this symbol. This symbol is called sigma. It's a Greek symbol, and we use that to denote standard deviation. So, what is standard deviation? So, standard deviation is just, it tells us how spread out my data is from the mean, from a central point, right? So, if I have a low standard deviation, that means all of my data is very kind of in or around the mean value. They're all like in and around the same value. If my standard deviation is very big, that means my data is spread out far from the mean. So let's look at these two groups just for a quick little example. So this is group A and group B. I just made these up. So group A here is 2, 2, 2, 2, 2, 3, 3, 3, 3, 3. So the mean here is 2.5, right? And then I calculate the standard deviation. I'm going to show you now how to do that in a minute. But the standard deviation is 0.5. It's very small, right? But if you're lucky here, right, my mean is 2.5. And that's like all of my data is in and around 2.5. Like I have 2, 2, 2, 2, 2, 3, 3, 3, 3. It's all in and around 2.5. So my data is very compacted and close together around 2.5. But if we look at B here, right, I have 1, 2, 5, 20, 31, 45. My mean of this data, so my average value of this data is 17.333. And as you can see, just by just pure inspection, right, before even calculating what my standard deviation actually is, but just off inspection, 17, that's ages away from 1. That's ages away from 2. It's ages away from 5. Yeah, it's close enough to 20. It's a fair bit away from 31. It's ages away from 45. So my data is not really centering around a mean value here. Hence why we got a big standard deviation of 16.4. So if I was to compare these two data sets, I say, well, the standard deviation of set A is smaller than the standard deviation of set B. Therefore, the data is more compact or more closer, or is all falling around a mean value, a central value. So as you see here, lower standard deviation, that tells us, oh, all of my data points are near my mean, which is true here. Here, higher standard deviation, all of my data points are kind of spreading out further away from my mean. Right, so let's look how to calculate the standard deviation without a calculator, and then we will look on how to calculate with a calculator. So I just made up a random data set here, 2, 2, 3, 5. So first step is you need to calculate the mean of the numbers, which is written as x bar, or x with a line, so x bar. So 2 plus 2 is 4, 4 plus 3 is 7, 7 plus 5 is 12, 12 divided by 4 is 3. So my mean is equal to 3. Next step, I find the difference of each variable from the mean. So I find x minus the mean for all of them. So my first difference, my second difference, third difference, fourth difference. So I have 4 numbers. So it's going to be 2 minus 3, which is minus 1. 2 minus 3, which is minus 1. 3 minus 3, which is 0. 5 minus 3, which is 2. Next, step 3, square each of these numbers. So if I was squaring these numbers, minus 1 squared is 1, minus 1 squared is 1, 0 squared is 0, 2 squared is 4. Then what I do is I divide the result. So step 4, find the sum of these values. So that's what this little thing here means. It means sum of all these values squared. So if I add them all up, 1 plus 1 plus 4, I'm going to get 6. Then divide the result by the number of numbers. So I have 6, and I have 1, 2, 3, 4 numbers in my data set. And 6 divided by 4 is, I'll tell you in a minute, 6 divided by 4, 1.5. Then finally, last step, I square root all of that, and that gives me my standard deviation. So square root of 1.5. Square root of 1.5, bear with. square root 1.5 is equal to 1.2247, right? So this was an easy one because I only had 4 data points, but it gets a bit tricky when we have a frequency distribution or we might have like 10 or 20 data points I need to do. So that's why we're better off just using our calculator. So there's no need to use formula, we use a calculator. So we have the old and the new calculator. I'll show with the new calculator. It might be, if I can get the old calculator up, I'll show that as well. So let's get my calculator up and let's double check my answer. So here's my handy dandy calculator. So remember, if I want to enter statistics mode, I click menu, then I click 2 for stats. I want to enter one variable, so I'm going to click 1 here. And that gives me my table here. So remember, if you don't have your frequency table here, it's not there for you. You have to click shift and then click menu because we want to enter setup. So shift, setup. Oh, not let me do it. Shift, setup. Why didn't let me do it? Being so rude. Hello. Shift, setup. There we go. Why is it being so rude? I have no idea. Right. So I go down one page, I click 1 for statistics, as you see that. Frequency on or off, I want frequency on, so I click 1. Anyway, but frequency was already on for me. So my data points were 2, 2, 3, and 5. So my frequency all was 1, so I can leave them. I click AC to save it. I now click option, then I click 2. And then it gives me a list of all my values there. So if you see here, the sigma x, that is my standard deviation, right? That's my standard deviation there. And if you're lucky here, 1.2247, it matches up, right? It matches up with this value here, right? So let's look at an example here. So the following data set represents the daily temperatures in degrees Fahrenheit recorded over a week. So 72, 73, 74, 75, 73, 76, and 78. We want to calculate the standard deviation of the daily temperatures. So step 1, we find the mean. So we add up all my values, divide by 7 because I've 7 of them. So we got the mean to equal 74.43. Next step, I find the difference from the mean. So my first point was 72. So 72 minus 74.43 is minus 2.43. 73 minus 74.3 is minus 1.43, etc., etc. So I do this for all my data points. I then square all of my data points. So I get 5.9 to 5.9, 5.9, 2.04, 0.18, 0.32, 2.48, 2.46, 12.74. Then the kind of standard deviation, I sum them all up, divide by 7 and square root it, and I get 1.92. But I think we can all agree, absolute effort. Effort. So we're just going to put it in our handy dandy calculator. So let's go back up to my data points here and enter it all in. So absolute effort. So I'm going to click menu, statistics, one variable. I don't need my frequency table part for this, so I don't need to put it on. But let's do 72 is my first point, 73, 74, 75, 73, 76, 78. Right, so there's my 7 points, AC to save, option, variable calc 2, and then if you see here, I get 1.91, right? Let me just pop this out here. Right, I get sigma x 1.9166. Right, and then if we look here, that is what we got there, 1.92. Yeah, which matches up with this value here. So gorge. So that's all it is on your calculator. So let's do some questions. So this is from the 2010 Leaving Cert sample paper 2. Use a calculator or otherwise find the mean and standard deviation from the data in the following frequency table. So we're dealing with a frequency table. So let's open up my calculator. Right, so we're gonna start a new table. So I'm gonna click menu, I'm going to turn that off. I'm going to click Menu, Statistics, one variable. I don't have my frequency part of my table, so I need to activate that. I'm going to click Shift, Setup. Down one, Statistics. Oh, I made a poo-poo. Oh no, I made a poo-poo. Shift, Menu, down one, Statistics, click one. Frequency, on, click one again. So, need to enter in my points here. So, where can I put this now? That helps. So, my points are 20, 30, 50. That's it. So, then go up to my frequencies here. So, 20 appears 16 times. So, let me just put this here now. Can you see it? So 20 appears 16 times, so type 16. 30 appears 38 times. 40 appears 26 times. And 50 appears 20 times. And click AC to save. Option, variable calculator. Boom. Right? So there is my standard deviation. My standard deviation is 17.15. So 17.15, and then my mean is 27.6. So X bar 27.6. So let's move this now. So my mean was 27.6. So my mean was 27.6, and my standard deviation was 17.15. Didn't really specify a decimal point there. Right, below, and then this rest of this question doesn't have anything to do with it, but might as well do it. Below is a stem and leaf plot of the height of groups of students in centimeters. How many students are in the group? 1, 2, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There are 20 students in the group. What's the range of heights? So, biggest from smallest, 157 minus 133. That is going to equal 24 centimeters. That's my range. What percentage of students are between 145 and 154 centimeters? So between 145 and 154. So 146, 146. 1, 2, 3, 4, 5, 6, 7, 8. Right? Because then we get to 155. So I have 8 students, and there are, don't know how many students, there's 20 students in total. So it'll be 8 over 20, which is going to be equal to 2/5. So there's a 2/5 chance of picking someone between them height. Right, okay, so let's look at the 2012 paper here. So this is a sample paper 2. So the mean, standard deviation, and size of 4 data sets A, B, C, and D are given in the table. So we have the size n, so how many are in the data set, the mean, and the standard deviation. So we see here, A has 1,000 points in it, B has 100, C has 100, D has 10. The mean of A is 10, the mean of B is 100, the mean of C is 1,000, the mean of D is 100. The standard deviation, so 20, 30, 20, and 10. So okay, complete the following sentences below by filling in the blank. So the set that contains more numbers than any other is, well, that's going to be set A, because it's 1,000 people in A. And then the set that contains fewer numbers than any other is going to be D. On average, the data in set blank are the biggest numbers, and the data in set blank are the smallest numbers. So on average, C has the biggest numbers and A has the smallest numbers. The data in set blank are more spread out than any other data, but that's going to be set B because it has the highest standard deviation. It has the highest standard deviation, that means the data is more spread out. The set that must contain some negative numbers has to be set A, right? Because if you think of it, there's 1,000 data points here and the mean is only 10, right? So obviously I'm going to have some really big numbers, and obviously I have some really big negative numbers. You add them all up together to find the mean. That's why we're kind of getting a low value of 10. And if the 4 sets are combined, the median is most likely to be a value in set blank. I'm going to say it's set A because A has the most numbers, it has 1,000. So if you're looking at, you know, like B only has 100, C only has 100, and D only has 10. So it's kind of more likely to be A because there's 1,000 numbers in D. One of them has a more likely chance of being the median there. Right, that's that question done. Does this one came up in the 2022 Leaving Cert Order level paper? Question 4. The scores of 6 people on a test where it follows: 104, 82, 94, 113, 98, 105. Find the range and standard deviation of these numbers. Give the standard deviation correct to one decimal place. So, range is equal to biggest from smallest. So 113 minus 82. 113 minus 82, so 113 minus 82 is 31. My range is 31. Next, we're asked to find the standard deviation. So let me open up my calculator here. Right, so let's move this here. So calculator, let's start this off. So menu to enter statistics mode, enter variable mode. So enter my numbers. 104 is my first one. Equals 82 is my second one. 94 is my third one. 113 is the fourth one. I have 98. And I have 105. Equals AC to save. Option. Click 2 for variable calc. So here my standard deviation is 9.75, but it says to round to one decimal place. So my standard deviation is 9.8. Right, 9.8. And that is my standard deviation there. Right, that was an exam paper. That's easy peasy lemon squeezy. Right, let's find this. The last one is an exam style one. This involves a frequency table. So calculate the range and standard deviation. So, well, my biggest value is 6. Right, so the range, biggest and smallest. My biggest is 6, my smallest is 0. So my answer is going to be 6. So the range is 6 birdies, right? Now let's calculate my standard deviation. So again, open up my calculator. Boom. So start my new table. To open my new table here, frequency. So 0, then it's 1, then it's 2, 3, 4, 5, 6. So 0 appeared 5 times. 1 appears 6 times. 2 appears 4 times. 3 appears 6 times. 4 appears 3 times. 5 appears once. And 6 appears 3 times. Gorge, have it all entered, double check. I'm going to click AC to save. Option. A calculator here. Here's all my stuff. So my standard deviation is 1.858. So 1.858. So that's a nice low standard deviation. So all my points are kind of closely compacted together. So that's an example of where you could be asked to solve for the standard deviation in a frequency table. And that, ladies and gentlemen, is how we calculate standard deviation, thus concluding this chapter. And I hope you enjoyed this journey, and I'll catch you guys later. Bye.